All right, let's jump right in. I want you to picture something. Forget the bubbling beakers and crazy experiments for a second. Instead, think of a chemistry lab as a crime scene. Every single substance, every sample is hiding a secret. And in this scene, the analytical chemist is our detective, with one mission: to uncover the truth hidden inside the molecules all around us. So, what are these detectives trying to figure out? Well, they're asking the big questions every single day. Is that medicine you're taking really the right dose? Is the water from your tap actually safe to drink? Finding these answers takes serious precision, the right set of tools, and, of course, a special language to interpret the clues. So, where do you even start? Well, just like any detective, you've got to gather your evidence first. And in analytical chemistry, that means measuring things with unbelievable accuracy. So, our first stop is the detective's toolkit, where every single piece of gear is designed for one thing, and one thing only: precision. Okay, take a look at these. At first glance, they might just look like some fancy glass bottles, right? But these are way more than that. These are highly specialized, high-precision instruments. On the left, you've got a volumetric pipette, made to deliver one and only one super exact volume of liquid. And on the right, a volumetric flask, built to contain a specific amount with pinpoint accuracy. These aren't just for holding stuff, they're for measuring with absolute certainty. And get this is the level of detail we're talking about. The markings here show that this pipette is accurate to within plus or minus 0.02 milliliters. I mean, that is a tiny fraction of a single drop. It's incredible. It just goes to show you, in this line of work, knowing how precise your tool is, that's just as important as the measurement itself. So, how do our detectives make sure their evidence holds up in court, so to speak? Well, they follow this rule called significant figures. Really, it's just a system to make sure you never claim your result is more precise than your least precise tool. It's like the chemist's code of honor, It keeps the final numbers honest and completely trustworthy. All right, so we've collected our evidence with our super precise tools. What's next? Well, now we have to actually interpret the clues. And to do that, you need to speak the language of chemistry, specifically the language of concentration. Now, the big one you'll hear all the time is molarity, which we show with a capital M. Just think of it as the standard way to describe the strength of a chemical clue. It tells you exactly how many moles of a substance, which is just a specific number of molecules, are packed into 1 liter of a solution. It's a direct measure of its chemical punch. But of course, it's chemistry, so there's always a little twist, right? You'll also hear about something called molality. Now, molarity is based on volume, but molality is based on mass. So why have two? Here's the kicker. Volume can actually change when things get hotter or colder. Liquids expand and contract. But mass? Mass never, ever changes. So for that super high-stakes, gotta-be-perfect kind of work, that little difference means everything. Okay, let's add one more to our vocabulary list, and this one's a biggie: normality, or capital N. This one is all about a solution's pure, unadulterated reactive power. It's not just about how much stuff is in there, but how much of a punch it can pack in a reaction. And this idea is absolutely crucial for the main event, the interrogation technique we're about to see called titration. All right, here we go. This is the moment of truth. Titration, this is the chemical version of a dramatic interrogation scene. It's where we put our unknown sample in the hot seat and don't let up until it spills its secrets. This is where the case gets cracked wide open. And it's a very careful, methodical process. First, our detective measures out an exact amount of the unknown into a flask. Next, they add a couple of drops of a chemical informant. We call it an indicator. Then from this long, skinny tube called a burette, a solution of a known strength starts coming out, drop by agonizing drop. And all our detective has to do is watch and wait for that one single moment when the reaction is perfectly complete. So just imagine it. You've got this perfectly clear solution in the flask. With a super steady hand, the chemist adds the titrant. Every drop makes this little flash of pink that just vanishes with a swirl. The tension is just building, waiting for that one drop that's going to change everything. And then, bam, it happens. A single drop hits the solution, and this time, the color stays. A beautiful, permanent pink. This is it. This is the endpoint. This is the moment the unknown has finally confessed, telling us exactly what its concentration is. Interrogation over. So we have our confession, right? We know the exact volume it took to get that color change. Now it's time for the final act. We take that critical piece of evidence, and we do the final deduction to solve this thing once and for all. And you know what? The key that cracks this whole case is this beautifully simple little formula: N1V1 equals N2V2. Look, we know the strength, the normality, and the volume of the stuff we added. We know the volume of our unknown sample. We've got 3 of the 4 pieces of the puzzle. The last one, the unknown concentration, it's just simple math from here. So what does all that math get us? It gives us a real, concrete answer to our mystery. For example, in one experiment, this whole process showed that a sample of rhubarb contained exactly 0.201% oxalic acid by weight. See? All that abstract chemistry leads to a tangible, meaningful number. Case closed. And here's the thing you have to remember. This isn't just some neat trick they do in a lab. The work of these chemical detectives ensures the safety and quality of almost everything you touch. Every single time you take a pill, drink a glass of water, or use a bar of soap, you're putting your trust in a process just like this. So it kind of makes you think, right? If you had the tools, what's the first mystery in your world you'd want to solve?